Hello and welcome to the wonderful course of Computer Network. And today we are going to discuss about end-to-end delay numericals. So let's take example from this book. You can see in modern packet switch network, including the internet, the source host segments long application layer messages, for example, an image or a music file, into smaller packets and sends the packets into the network. The receiver then reassembles the packets back into the original message. We refer to this process as message segmentation. As we have already discussed that in packet switch network, we break our packet, a complete message. We break our complete message into n number of small packets, and then we transmit those packets individually to its destination, and after that it gets reassembled at the destination. So figure 1.27, which is over here, illustrates the end-to-end transport of a message with and without message segmentation. Consider a message that is message size is 8.8 into 10 to the power 6 bits long, that is to be sent from source to destination in figure 1.27. Suppose each link in the figure is 2 Mbps. These are the 3 links available in this particular network, and each link is of this is called transmission rate of the links, that is 2 Mbps. Ignore propagation, queuing and processing delay. So if we have to calculate the end-to-end delay, then 4 types of delays are there, out of which we have to ignore propagation, queuing and processing delay. So the delay which is left is transmission delay. It is all about L by R. We have already discussed this thing, L by R. So as you can see, the diagram which is mentioned in figure 1.27, that 2 computers, source and destination, are connected with 2 routers. First one is this, second one is this. So these 2 end systems are connected with 2 routers and 3 links, 1, 2 and 3. The transmission rate of all these 3 links is 2 Mbps, and the message is 8 into 10 to the power 6 bits long, and you have to send this particular message from this point to this point in 2 ways. The first one is it is mentioned in this particular question that you have to send it transport a message with and without message segmentation. So these are the part of these questions we will discuss and solve this particular question. So here we have a computer, and this is the source one. We have this is destination, and these 2 end systems are connected with 2 routers, as we have already mentioned in the question, and there's a message of size 8 into 10 to the power 6 bits long. And the transmission delay of all the three links are mentioned in the question, that is 2 Mbps. So now our first part of the question says, consider sending the message from source to destination without message segmentation. How long does it take to move the message from the source host to the first packet switch, keeping in mind that each switch uses store and forward packet switching? What is the total time to move the message from source to destination? So here is the first part of this particular question, which I just read it for you. So we will calculate two things in this first part. The first is, how long does it take to move the message? First of all, you need to focus that we have to send the complete message without message segmentation. And how long does it take to move the message from source host to the first packet switch? So you can see over there, this is the source computer and this is the first packet switch. So how long does it take to transmit the complete message without message segmentation from this point to this point? And second, it asks that what is the total time to move the message from source host to destination host? So these are the two parts in this first part of this particular question. So let's solve them. So your complete message is this. So first of all, we need to calculate the time delay when this particular complete message starts from this point and reach to this particular first packet switch. So it would be very easy, like first part, transmission delay, it would be L by R. What is L? 8 into 10 to the power 6 divided by 2. R would be 2 Mbps. So 2 into 10 to the power 6 bits per seconds. I have to convert this particular 2 Mbps into bits per seconds. Then I have to multiply this 2 with 10 to the power 6 because it's in megabits per seconds. So this much is the time required by this size of message to reach from this source computer to the first packet switch. And the second part says time required by this particular message to reach from source to destination. So this would be again transmission delay of this link, transmission delay of this link, and transmission delay of this link. So end-to-end delay would be L by R plus L by R plus L by R. So it would be 8 into 10 to the power 6 divided by 2 into 10 to the power 6 into 3. So this would come out 4 seconds, and this would come out 4 into 3, 12 seconds. So this particular question is very easy, because in this particular part of this particular question we did not have to divide this whole message into small packets, and we just need to transmit the complete message from source to the destination. So that's why it's very easy. Now let's solve the second part of this particular question. I hope you understand this this particular part of the question. Now part B says, now suppose that the message is segmented into 800 packets. With each packet being 10,000 bits long, packet size, bits long. How long does it take to move the first packet from source host to the first switch? When the first packet is being sent from the first switch to the second switch, the second packet is being sent from the source host to the first switch. At what time will the second packet be fully received at the first switch? How long does it take to move the file? It is the third part of this particular question. How long does it take to move the file from source host to destination host when message segmentation is used? Compare this result with your answer in part A and comment. So we are going to discuss both these parts. In the first part, it says that the the complete message of this size is divided into 800 packets, with each packet size is 10,000 bits long. And now how long does it take to move the first packet from source host to the first switch? From source host to the first switch, it is talking about the first packet. Okay, and the second is when the first packet is being sent from the first switch to the second switch, from here to here. When the first packet is being sent from first switch to the second switch, from this to this point, the second packet is being sent from source host to the first switch, from there to there. I'll make you understand. Just give me a moment. At what time will the second packet be fully received at the at what time will the second packet be fully received at the first switch? Okay, let's understand the concept of this particular question. Now, first of all, when you divide this particular complete message 8 into 10 to the power 6 by 800, then the packet size would come out (10,000) bits. So packet size is this. Now, how much delay is there? How much time is required to send the first packet from the source to the first packet switch? So it would be, all the other delays are ignored as mentioned in the question. So only delay is left is transmission delay, which is L by R. So here L is 10,000 and R would be 2 into 10 to the power 6. So this would come out. So it would be time required by first packet to reach from source to first switch would be this much of seconds. Now the second part would be Second part would be let's understand the concept of message segmentation and how the packets are transmitted from source to the destination. Let's suppose we have some packets which are aligned in a queue at this particular point 1 2 3 4 and when this first packet reach at this particular point, second packet over here is ready to get transmitted into this link. So second is there. When this packet is being transmitted from first switch to the second switch from here to here, during that time second packet is getting transmitted from source to the first switch. So during the same time when first switch is getting transmitted from this first switch to this second from first router to the second router, during the same time second packet which was aligned first in the queue is getting gets transferred from source to first switch. And when this particular first switch first packet is transmitted from second switch or second router to the destination, during the same time second packet is getting transmitted over here, and during the same time this third packet will get transmitted from first switch to the from source to the first switch. I hope you understand this concept. Let's understand this concept again. You have this computer source. This is first switch. This is second switch, and this is your destination. You have 1 2 3 4 these packets aligned in a queue. These are the part of a message. That message is divided into 4 packets. Let's suppose when your first packet transmits from this source to the first switch, second would be here. It is ready to get transmit from source to first switch. During the time when your first packet is transmitting from first switch to the second switch, during the same time your second packet transmits from source to the first switch, and this one is here. Now when your first packet is transmitting from second switch to the destination, during the same time your second packet is transmitting from first switch to the second switch, and during the same time third packet is transmitting from here to here, and fourth is in the queue. So when first packet is here, second one is here. When second packet is here, third one is here. When third packet is here, fourth one is here. So let's understand this thing. Packet size is 10,000 bits. How long does first packet take to reach from source to destination? It would be this L by R, this L by R, and this L by R. So it would be for first packet, it would be from source to destination. From source to destination, it would be 10,000 divided by 2 2 into 10 to the power 6 plus 10,000 divided by 2 into 10 to the power 6 plus 10,000 divided by 2 into 10 to the power 6. So it may be 3 links are there. You can do it in this way. So this much is the time required by first packet to reach from source to the destination. But rest other packets, how many packets were there? We had 8,000 packets, I hope. Sorry, 800 packets were there. So first packet takes this much amount of time. And as I told you few minutes back, that when first packet is at the destination, second is here. When second packet is at the destination, third one is at the second last packet switch. When third packet is here, fourth one is here. It means rest all other packets, which are 799, takes time from second switch to the destination. So it would be around 10,000 into 10 to the power 6. This much is the time required by first packet to reach from source to destination. Rest 799 packets need only this much transmission delay, because when first packet is here, second is already there. When second is there, third one is already there. And when third one is there, fourth one is already there. So rest other 799 packets takes this much amount of time. So when you do message segmentation, that means when you divide your complete